Hello everyone, it's time to graph some inequalities. We're going to graph two on the same XY axis here, and then we're looking at the overlap, and that's going to be kind of the main thing we're concerned about. So these are in standard form right now. You may remember standard form is AX plus BY equals C, and you can, if you really want to, you can convert it to slope-intercept. So I'm really going to graph the line negative x plus 4. But I'm going to try and graph it using standard form. And to do that, you find intercepts. So what I'm going to do is plug in 0 for x and 0 for y. So something 0. If I plug in 0 for x, that goes away. And you can look, it just says y. We're going to just pretend that's an equal sign for now. Y equals 4. So when you plug in 0 for x, you get 4 for y. And then similarly, if you plug in 0 for y, well, then you get x equals 4. So the x and y intercepts are both 4. So I'll put it out at 4. And since you only need 2 points to graph a line, I got 2 points. I'm just going to graph those 2 points. Okay, you can see that the slope is negative 1 and the y-intercept is 4 if you convert it. That's one way to do it. Now, that's if you're just graphing a line. However, this is an inequality, so there's two things we need to look at. Number one, it's a less than or equal to, so that means we are going to use a solid line. It's not a dashed line. This one will be dashed. I'll show you in a second. We're using a solid line, which means if you pick an ordered pair on that line, like if you pick 4, you will get 4 plus 0, and 4 is less than or equal to 4. So it works. It's the boundary, and it is inclusive. It works. Okay? The other thing we need to do is test an ordered pair to see where all the values are less than 4. So what I'm going to do is plug in an ordered pair. It doesn't matter where on this grid you pick. I'm going to pick 0, 0. Right there, test that point. Does that make a true statement? Is 0 plus 0 less than 4? It is. So I'm going to shade towards it. And I'm not going to actually color anything in because I'm going to have to focus on the overlap. But this is the region I'm talking about. Any ordered pair in this region will satisfy the constraints of that inequality. If you pick this point right here, negative 10, negative 10. Negative 10 and negative 10 is negative 20, and negative 20 is less than or equal to 4. So once you understand what we're doing here, that's where I'm at. Okay, I'm going to unshade this though, because I'm going to have to find the overlap. So I'll just use arrows. I'll do the same thing with the other one now. So the x and y intercepts, if you plug in 0 for x and y, if you plug in 0 for x, this goes away, and you get negative y equals 4, so that means y equals negative 4. So the y-intercept is negative 4. And then if I plug in 0 for y, 2x equals 4, so x must be 2. So that is my x-intercept at positive 2. Now, because this is strictly less than, I'm going to use a dashed line. So when I draw it, I can do better. Looks something like that. I'm going to make this a dashed line, and what that means is if you pick a point here, like if you pick 2, you get 2 times 2. You get 4 is less than 4. You're like, well, 4 is not less than 4. 4 equals 4, so it's on the border. So the distinction is it doesn't work. It's not equal to. Now, I'll test another point. And again, I always test the origin if I can because it's the easiest thing to plug in. Is 0 plus 0 less than 4? Yes, it is. So all the points on this side work. So I will shade towards those. And what I'm concerned about is the overlap. And if you look carefully, that's this way and this way. So the overlap is right here. This is the solution set. So this is what we want to shade in. And what this is saying is that any ordered pair you pick right here will work in both inequalities. Let's try this one. Negative 5, 0. Is negative 5 plus 0 less than or equal to 4? Yes. Is 2 times negative 5 minus 0 less than 4? Is negative 10 less than 4? Yes, it is. So if you pick an ordered pair in the shaded region, it should work in both inequalities. That's a lot for the first one. We should be able to get the ball rolling a little bit faster now. So first thing, I'm going to plug in 0 for x and 0 for y, and we'll see what our intercepts are. If I plug in 0 for x, then I get y equals negative 1, so the y-intercept is negative 1. That's right here. And if I plug in 0 for y, I get x equals negative 1. Okay, so the x and y intercepts are both negative 1. That looks like this. And since it's a less than, not less than or equal to, it will be a dashed line. Now we will test an ordered pair. I will always pick 0, 0 because it's easy. So is 0 plus 0 less than 1? Is 0 less than negative 1? No, 0 is greater than negative 1. So since 0, 0 does not work, then none of these points on this side will work. That means all of the points on the other side must work. So since 0, 0 didn't work, I'm shading away from 0, 0. There's my first one. The second one is x is less than 2. Remember, that's a vertical line. So x is less than 2 right here. And since it's less than, it would be a dashed line. And the numbers that are less than 2 are to the left of 2. You can imagine plugging in 0. That's another way of thinking about it. Last one, y is greater than or equal to 0. So that's a horizontal line. It is a greater than or equal to, so it will be solid. And the numbers that are greater than 0 are above. So where's the overlap for all of them? It's this guy right here. That's the shaded region for all three. So this x is less than 2 doesn't do a whole lot. But that is the shaded region. That is the solution set. All right, let's say here, it says, tell whether the ordered pair is a solution. So 10, negative 16. If I plug in 10 and then negative 16, does this make a true statement? Is 10 plus 48 greater than 3? Yes, it works in the first one. If I plug in negative 16, is negative 16? Yes, it works in both. So since it works in both, yes, it is a solution to this system. 2, 1. 2, 1 is right there. See how it's on the dashed line? If it's on the dashed line, that means it's not inclusive, so that one will not work. What about 4, 3? 1, 2, 3, 4, 1, 2, 3 right there. That is in the overlap, so yes, this one is a solution. I would say no, that's not. All right, let's see. Can we write systems of equations? Let's just find the y-intercept and count the slope. So this one would be y, and it's underneath, so less than or equal to negative 2x minus 1. The y-intercept is negative 1. That's right here, negative 1. And the slope is down 2 over 1, so negative 2 over 1 is the slope. That's this line. I'll make it green so you can see it. The other one I'll do in red. That's this guy. And it's a strictly greater than, because it's a dashed line. So I'm going to say y is greater than. The y-intercept here is 0, and the slope is 3. So it'll say 3x. And since it's up, we shade above. So that's this way. Okay? Let's see. This is counting by 2's. You got to be careful. That's 0, 1. What's the slope? Down 1 over 1. So y equals, well, it would be less than, is less than negative x plus 1. That's this one. The slope is negative 1, down 1 over 1, down 1 over 1, and the y-intercept is positive 1. For this guy, we'll do this one in blue. The y-intercept is, remember, you count by 2, so that's negative 4, and the slope is up, how many? Up 2 over 1, so y is greater than 2x minus 4. The slope is 2 over 1. The y-intercept is negative 4. And the last one is a vertical line, and we're shading to the right. So x is greater than, that's negative 2, greater than or equal to, because it's a solid line. Mostly what I need you to be able to do is graph these, not go backwards. So this isn't going to be the focus. This is more like what you're expected to do. So let's do the practice problems, and then we'll be done. Let's plug in 0, 0 because it's in standard form, or I'm sorry, 0 and 0, not at the same time. If you plug in 0 for x, you get y equals 6. If you plug in 0 for y, negative x equals 6, so that is negative 6. So the intercepts are at 6 for the y-intercept and negative 6 for the x-intercept. Since it's a less than or equal to, I will keep a solid line. And then when I test the order pair 0, 0, since 0 is less than 6, this point works, so all the points on that side work. We're going to shade towards it. The other one is in slope intercept, so you start at negative 1, and you go down 3 over 2. And I have my straight edge here, so I don't need to do it a bunch. If I draw it well, there you go. A little better, right? Yeah, okay. And again, greater than or equal to, so it's a solid line, and when you test 0, 0, 0 is greater than negative 1, so since 0, 0 works, since this point works, we shade all the points on that side, and then you can see the overlap would be right here. So the solution set is the overlap. That's all I really care about. Where are they both true? All right, let's try another one. Plug in 0 for x and 0 for y. If you plug in 0 for x, you get 2y equals negative 2, so the y-intercept is negative 1. If you plug in 0 for y, negative x equals negative 2, so x equals positive 2. So 0, negative 1. Positive 2, connect your dots. Let's see. It is a greater than or equal to, so solid line. And when you test the ordered pair 0, 0, 0 is greater than negative 2, so we're shading towards the origin. The origin works, so we shade towards it. I'll do the other one here. The y-intercept is 1. The slope is negative 1/4, so down 1 over 4. Once you've got 2 points, you can draw your line. This is a less than, so it's going to be a dashed line. And the numbers that are less than, if I test in 0, 0, 0 is less than 1, so I shade down. 0 is less than 1, so since 0, 0 works, all the points on that side work. And then when I highlight the solution set, it looks like this. So any point from there will give you a solution that works in both. Last two, x is greater than or equal to 2, shade to the right of x equals 2. We're going that way. Y is greater than or equal to 1, horizontal line. We're going up. So we're just kind of moving the feasible region out here a little bit. Now the last one, I'll start at 4. The y-intercept is 4, down 1 over 2. So it looks something like this. This is also less than or equal to, so solid line. And when you test the ordered pair 0, 0, is 0 less than 4? No. So if this point doesn't work, we're going to shade away from it. So the overlap then is right here. So it just kind of gets the corner chopped off a little bit. There you go. So any point here will work in all three. Last one, x is less than or equal to 9. Okay, that's right here. We're going left. Y is less than or equal to 4. That's right here. Oop, that didn't work. Right here. And less than means we're going down. So right now I'm in this area. And the last one, start at 8, the y-intercept, and go down 2 over 1. And we want to test 0, 0. Is 0 greater than 8? Is 0 greater than 8? No. So if this point doesn't work, we don't shade towards it, we shade away from it. So where's the overlap? To the left, down, and up. So it's this triangle right here. This is the solution set. Okay, so any point in there will work in all three. All right, so this is practicing graphing inequalities. We're going to use this to do some word problems. Make sure you get your homework done. Make sure you smash that like and subscribe.